Okay, this is section 3.2 titled angles of triangles. And so when we're talking about angles of triangles, we typically think the angles inside of triangles. And so those are called interior angles. And this chapter, although this particular section is about triangles, we're going to be looking at the interior and exterior angles of all polygons, not just the three-sided triangles. So a polygon, poly means many and gon means sides. So many-sided. So basically a triangle would be your smallest polygon that you have with three sides, because you can't have a polygon that only has two sides. They won't connect. I mean, if you try to connect them, they'll just make a line. And then you have quadrilaterals and you have so on and so forth. We'll talk about the rest of them. So interior angles are the angles inside of a polygon. And so we'll start with a very famous theorem. In math, a theorem is something, usually we talk about theorems in geometry, something that's been proven over and over and over again to be true. And so this is called the Triangle Sum Theorem. And it states that the sum of the measures of the interior angles of a triangle is 180 degrees. Says the sum of the measures of the interior angles of a triangle is 180 degrees. So if I had three angles, call them X, Y, and Z, they would all add up to be 180 degrees. You guys probably already knew that because you used it quite a bit last year as sixth graders. Okay, that's called the Triangle Sum Theorem. We're talking about the sum of the interior angles. When we come back to school on Monday, I'll have a because we're not in school today, I'll have a little thing we can do a proof of this theorem that shows you that it's always true, no matter what size or shape triangle you have, that the angles add up to 180 degrees. I would have done it today with you guys had we been at school. And so let's start by using that to answer or define our missing values in these triangles. So in this red triangle here, we're finding the value of angle X. Now, let me be very clear when you guys are doing this. I know that you could probably do this without showing any work, but what I want you to do is I want you to write an equation. Now, your equation would look like this then. X, which is our missing angle, we'll start with that, plus, now I'm not going to make you write out everything. If you want to go ahead and combine your like terms, for example, we're going to do 32 plus 48 because those three angles are going to add up to be 180. Instead of starting at this equation, if you wanted to start at this equation, and already go and combine those like terms, you could start here. That's perfectly fine. But I do want you guys on your work papers for 3.2 to show equations, because that's what the sum theorem says, is that if I add these three angles together, I'll get 180 degrees. So if you want to add 32 and 48 together, I think my math's checking out on that. That should be 80. And then you can solve for X. And so what would X be for this triangle then? Anybody can shout it out.
100.
100, yeah. Now, if it says, what's the measure of the missing angle? I would put 100 degrees. But if it just says solve for X, then you can just write X equals 100. You don't have to put the degrees. If you want to put the degrees, that's fine, just so you can cover your base. Make sure that everything's labeled properly. That's fine. I'm not going to count off if you didn't put a degree symbol when you're solving your equation. But if it says, what is X? Now find the measure of these other angles, then you would want to label those angles with degrees. Okay, let's go on to angle B, or to triangle B. We've got a triangle that has another missing angle X. And so if I add X with the 81 degree angle and the 25 degree angle, that's going to give us 180 degrees. So can someone add 81 and 25 for me and tell me what our like terms combine to?
106.
106, awesome, okay. And so again, if you wanted to start on your work paper, just right here where I'm currently at, that's perfectly fine. If you just want to write X plus 106 equals 180, and then what's X going to equal?
74.
74, awesome. Yeah, and notice I'm not putting -106, -106 on both sides. I mean, you can show that work if you want to, but we've solved enough equations by now that this is going to be pretty, these are pretty basic equations compared to ones we've looked at earlier this year. Okay, now let's get slightly more complicated, not much more complicated here in this next example. We've got x plus 28 plus the other x angle plus, and then what's our third angle? What angle have I left off so far? Xander?
The right angle.
The right angle, yeah. What, Xander, what's a right angle measure?
90 degrees.
Perfect, okay, so if I started from scratch, that's what my equation would look like. Now, notice I did not put the x plus 28 in parentheses like they did, because I'm just going to be adding all this together. So the fact that it's in parentheses really doesn't mean anything. So I'm going to combine my like terms. Buddy, stop. I'm going to combine my like terms to get two x's here. And then 28 and 90 would combine to give us 118. And instead of having a one-step equation, I just have a two-step equation. I'm going to go ahead and do both steps though. The first thing I would do is get rid of the 118. So can someone tell me what 180 minus 118 is?
62.
62, okay. So 2x equals 62. And then now we're going to divide by 2. And someone do that for me.
$31.
31. X is equal to 31. All right, moving on to our last one here. Purple triangle here. We've got x plus x minus 35. So think of that as a negative 35 plus 43 is equal to 180. I'm running out of room here. So when we combine our x's, we're going to have 2x just like before. What do we get when we combine negative 35 and 43?
8.
8, yes, 8. Yeah, so because they're different signs, we're going to subtract that, and we have more positives than negatives. So that takes all the way back to our integer rules that we reviewed at the beginning of the year. Yeah, so make sure you're checking what signs are in front of the number as you're combining them. And then we'll subtract 8 from both sides, which is going to give us 172. And then can somebody divide that by 2 for me and tell me what x is going to be?
$36.
36. Wait, what did you say? 36. Did you just
Oh, wait.
do 172?
86.
86. That sounds better. Yeah. Okay. So the important part to remember here is when we're solving this on our homework paper that we are writing them out as equations, even if we don't start at that start from scratch. If you want to combine your terms, like for example, with this last triangle we did, if you just want to jump right to this part, that's perfectly fine. You can just start with 2x plus 8 equals 180 and then solve that. Okay, so exterior angles. This should be new for us though. We've talked about interior angles, or at least you have in previous years. Exterior angles are the adjacent angles extended outside the polygon. So these are exterior angles on a triangle, okay? Now, the triangle exterior angle theorem states that when the measures of an exterior angle of a triangle equals the sum of the measures of the two non-adjacent interior angles. Okay, so let me repeat that. The exterior angle theorem states that the measures of an exterior angle of a triangle equals the sum of the two non-adjacent interior angles. So this exterior angle here, which we'll call Z, is going to be the sum of the non-adjacent, so we know adjacent means next to, so non-adjacent would be not next to. So I'm not referring to this angle here. I'm referring to the sum of the two non-adjacent interior angles, okay? So Z would be equal to X plus Y. Okay, so let's see how that applies down here for this first example. We've got X, which is our exterior angle, and that exterior angle is going to be equal to the sum of the two non-adjacent interior angles, which is 36 plus 72. So that's what I would write on my word paper, and then I would just answer that. Can someone tell me what 36 plus 72 is?
108.
108. Now, there's another way that you could find out what X is without having to use the exterior angle theorem. You could say, using the interior, the triangle sum theorem, looking at the interior angles, that you know that all three angles have to add up to 180 degrees. And so if you take 72 and 36 and get 101, sorry, Xander, I wrote 180. Because I can't talk and speak at the same time. There we go. And you get 108 when you add those together. Then you would take 180 and subtract 108 from it. And so 180 minus 108 would be, trying to do the math here, would that be 72? I think it's another 72, is it not? 144. Yeah, that looks right. And then you would take, and then you would use the fact that these are supplementary angles sitting on a straight line, and you would take 180 minus 72, and that would give you the 108 degrees that we have out here. Problem is that's way too many steps. And essentially what you're doing when you add the 36 plus the 72, that's going to give us the 108. Right? You don't have to take 36 plus 72, subtract it from 180, and then take that and subtract that from 180 because it's going to undo itself and you're going to get 108 degrees. So essentially it's just using common sense. Since triangles add up to 180 and straight lines add up to 180, just by adding the 36 and the 72 degree angles together, we have that missing exterior angle. So it saves us the extra time. Okay, let's move on to the example B here. The exterior angle on this triangle is Y. And so we know Y is going to be equal to the sum of the two non-adjacent interior angles, which is 40 plus 30. And what's 40 plus 30?
70.
70. So Y is equal to 70. Okay, now they're going to step up the difficulty here slightly. Now the exterior angle we have here is 2A. So 2A is going to be equal. My goodness, that is loud. So 2A is going to be equal to A minus 5 plus 80, the sum of the two non-adjacent interior angles. So we're going to combine our like term. Hang on one second. Hey, can you play with your goals? Thank you. Play with those. Thank you very much. This is very loud. Okay, sorry about that. Okay, so when we combine the 80 and the negative 5, what's that going to give us? What do we get when we combine those?
75.
75. At the same time, we know that we've got variables on both sides of the equation, and so we're going to have to subtract A from both sides. So we can get our variable just on one side. Remember, we at the beginning of the year, towards the beginning of the year, we had equations that had variables on both sides. And so 2A minus A is just going to be 1A, and then that goes away. And then we just said that negative 5 and 80 makes 75. So A is going to be equal to 75. Make sure I read this. Okay, so look at the instructions here for these examples. It says find the measure of the exterior angle. When you see that word measure, that means we're looking for an angle measurement. So I need to go back and put angle degree symbols on example A and example B. I need to put degree symbols because it said measure. We didn't see that in the last few examples that said just find the value of X. So find the value of X means X equals my number and I'm done. But when it says find the measure of exterior angles, that means we need to label them. And then that means we're not actually done with example C then. So if A is 75 degrees, we need to plug that in and we need to times by 2. So what would 75 times 2 be then? He's being a little loud. What's 75 times 2? Just stay down here. Still waiting.
150.
150, and then we're going to label degrees. 150 degrees. Yeah, so anytime it says what's the measure of that angle, we're going to label it degrees. Okay, let's check out this last example, example D. The exterior angle is 4n minus 20. And I know that that's going to be equal to the sum of the two non-adjacent interior angles, which are this angle and that angle. And so that's going to be equal to 2n plus 20 plus the third angle, n. Okay, so notice that I'm not adding these. That's a common mistake I see when I grade quizzes is people will take these angles and they'll still try to add them to 180. These do not add to 180. These two angles inside the triangle add to give you the outside angle, the exterior angle. So I need to put equals before n minus 20. Let's combine our terms here. We've got 4n minus 20. And then here we have 2n and 1n, which is going to give us 3n plus 20. What's my next step? Can someone explain to me the next step in solving this equation?
I would get rid of the negative 20 by adding 20 to both sides.
Okay, add 20 to both sides. What else? We can kill two birds with one stone here. What else are we going to have to do? If we have the constant on the right side, like Maddox just said, what else should we do?
Subtract 3n.
Yeah, we should move the
Both
variable.
sides.
Yep, move the variable over to the left side. So now we have this equation, which says 4n minus 3n, which is just n, and 20 plus 20, which is just 40. So once we get n equals 40, it says, what's the measure of that exterior angle? So now I need to plug 40 in for right here, or plug 40 in for n. And so that means I'm going to do 4 times 40 minus 20. Okay. Shane, what's 4 times 40?
160.
Awesome. Subtract 20 from that. Shane, subtract 20.
140.
There you go. So our missing angle is 140 degrees. I'm actually going to put it right here, where that arrow, because it's not the interior angle, it's the exterior angle. So my answer is 140 degrees, and I had to solve for n. And this one, remember, was 175 degrees. So I'll circle that. No, 150. It was 75 times 2. And the rest of them, when I just found X and when I just found Y, I actually had my answer. So I just have the degree symbol after it. But when they give you the 2a or the 4n minus 20, you have to go ahead and figure out what that angle is. Okay, let's move on to the next example. An airplane leaves from Miami and travels around the Bermuda Triangle. Maybe you've heard of the Bermuda Triangle before, where back, years in the past, before they had GPS, a lot of ships and planes went down in this area, lost at sea. And so the Bermuda Triangle goes from Miami, Florida, through the Bahamas to Puerto Rico, and then up to Bermuda. Okay, so you can see it there. And so they want us to find angle X. Now, is angle X inside or outside the triangle?
Inside.
Yeah, so this is going to be the Triangle Sum Theorem. I'm not going to use the exterior angle theorem that we just used. We're going to use the sum theorem, which states that if I add up the 3 angles inside of a triangle, it's going to give us 180. So I'm just going to go ahead and write that down. X plus 2x minus 44.8 plus 62.8 because they're inside the triangle, are all three going to add up to 180. So I'll combine the x terms for us. 1x and 2x makes 3x. Can someone tell me what negative 44.8 plus 62.8 would give us?
I mean 18.
18. Okay, I was gonna say 18 is what I was getting in my head. Does that make, can someone else confirm that? I don't want to do this problem. I don't have my calculator with me. I'm thinking this is 18.
It's 18.
18. Okay. Yeah, that's what I was getting in my head, but you know, I don't always trust my head. All right, so 3x plus 18 equals 180. We'll subtract 18 from each side. That's going to give us 162. And then can somebody divide that by 3 and tell us what x is?
$54.
54. Okay. And then reread the instructions. It says find x. So I'm done. I don't have to label it with a degree symbol. If it says what's the measure of that missing angle, then I would have to use a degree symbol and possibly do a little bit more work if x wasn't by itself already. Okay, let's look at these two. This problem. The measures of two complementary angles have a ratio of 3 to 6. What are the measures of each angle? Okay, so forget triangles for a second. We're back to complementary angles. Deegan, can you remind us, two complementary angles are going to add up to what?
180 degrees.
That's supplementary. You're thinking supplementary.
Yeah, 90 degrees.
90, yeah. So the way I remember complementary and supplementary is just complementary comes before supplementary alphabetically, and then 90 comes before 180. It's kind of a stupid way, but it works. So I know that these two angles are going to add up to 90. So where I'm going to start with this, and the reason I put this one down here is because I see a lot of questions like this show up on IXL. Maybe you might even see one in your homework on big ideas. But what I start with is, since I know that there's two angles that have to add up to 90, is I'll put x plus x equals 90. I just start with that. And then when it says it has a ratio of 3 to 6, I make my first angle 3x, and I make my second angle 6x. And that's all you have to do. So this problem seems very confusing with the ratio, but I just have to make it 3x and 6x adding up to 90. So you do have to know that complementary angles add up to 90, because if you put 180, you'll get your answer will be thrown off. And so now we can solve this by making it 9x equals 90 and x equals 10. But I'm not done. It says, what are the measures of each angle? So let's talk about the 3x angle. If x equals 10, what's 3x equal?
$30.
Okay, so I'm going to put 30 degrees. Remember, when it says measure, we put the degree symbol. And then the 6x angle, what's that going to be?
60.
60, exactly. And then you can double check to make sure your math, oops, hang on a second. You can double check to make sure your math checks out. 30 and 60 do add up to give you the 90 degrees for those two complementary angles. Okay, so this would be our answer. X equals 10 is how we find our answer, but our answer is actually 30 degrees and 60 degrees. That's a bad looking. I need a new stylus. Okay. Let's move on. The measure of the second angle in a triangle is 4 more than the measure of the first angle, and the measure of the third angle is 8 more than twice the measure of the first angle. Find the measure of each angle of the triangle. That's kind of confusing. It does say measure, so we are going to label with degree symbols. We do know that the angles, the 3 angles of this triangle, are going to add up to 180 degrees. So it says the measure of the second angle in a triangle is 4 more than the measure of the first angle. In fact, the third angle also relates back to the first angle. So why don't we call the first angle x, since we don't know what that is? I know that the first angle, I'll call angle 1, plus the second angle, plus the third angle, all have to add up to 180. It's just a matter of writing an expression for the second and third angles. So X is their first angle because we don't know what it is. The second angle is 4 more than the first angle. How would I write 4 more than the first angle?
4x.
That's 4 times the first angle. 4 more than. What would 4 more than be?
X plus 4.
Got it, X plus 4. And so I do need to write the X again because it's the first angle with 4 more degrees added to it. If I just put plus 4 with no X, then it's just saying that angle's 4 degrees. It didn't say that angle was 4 degrees. It said it was 4 more than the first one. So put X plus 4. That's good. Okay. Now, Owen, I'm going to come back to you for this third angle. This one says the third angle is 8 more than twice the measure. So Owen, how would I write twice the first angle?
2x.
Perfect. Yep. And then 8 more than that would be just plus 8. And I've got all 3 angles accounted for now. X plus the second angle, which is X plus 4, plus the third angle, which is 2X plus 8. And so I'm going to combine all of my like terms here. I see a total of 1, 2, 3, 4 X's. And then for my constants, 4, 8 gives us 12. What do you get when you subtract 12 from 180?
$168.
168. Okay, and then divide by 4, so we get X by itself.
$42.
42. Okay, so X equals 42. So now we're going to go back up. It said find the measure of each angle. And so we know the first angle has to be 42 degrees because that's what X is equal to. The second angle is going to be 4 more than that, so 46 degrees. And then the third angle is going to be twice the first angle plus 8. So 42 times 2 plus 8. What would the third angle be?
$100.
92.
92. Yep, 92 degrees. And notice how I'm putting degree symbols next to each of them. And then an obvious double check our answer would be just to add these 3 up and make sure you get 180. 42 and 46 makes 88, and 88 and 92 do add up to 180. So that makes sense. We have our correct answer. Okay, so now I know that our time is getting close to being done, but I've got a few homework problems I thought I would do with you guys. And I know they're multiple choice, but I always like it when I understand the multiple choice instead of just guessing and checking. So number 15 says, describe and correct the error in finding the measure of the exterior angle. This is the most common mistake I see with exterior angles, which is you just add the 3 angles together and set it equal to 180. And that is not what you do with exterior angles. That's what you do with the 3 interior angles. So their answer is clearly wrong. And to do it correctly, I don't like this. I wish they would just actually ask you for the answer. But to do it correctly, I would have to set the 2x minus 12 equal to the 30-degree angle plus the x degree angle. So the exterior angle is equal to the sum of the 2 non-adjacent interior angles. So for number 15, I want you to actually solve this equation, not just put A, B, C, D. I want you to actually have your work for number 15. So let's do the work right here in this space. What would my first step be to solve this equation? I need to separate my variables and my constant terms on 2 different sides of the equation. So where could I start?
Subtracting X.
Okay, so subtract an X on both sides. That's going to move my X's over to the left. And then how do I get rid of the negative 12?
Adding 12.
Adding 12. So even these slightly complicated equations are way less complicated than other ones that we've looked at this year. 2x plus x is going to give us, or 2x minus x is going to give us 1x. On the other side, I've got a 30 and I've got a 12, which is going to give us 42. So x is equal to 42. They asked you to find the measure of the exterior angle. So if I know x is, what we say, 42, then if I plug it in right there, 2x is going to be 84. And 84 minus 12 is, see, 84 minus 10 will be 74. Minus 2 more should be 72 degrees. So it should be 72 degrees, which means we'd have to go with this answer choice here. So make sure for number 15 that you're putting that work down and not just guessing and checking on it. All right, number 18. A triangle has an exterior angle with a measure of 120. Can you determine the measures of the interior angles? Explain. So if I told you, and I'm just going to draw a random triangle here. I have no idea if this is what it looks like. I mean, that kind of looks like a 120-degree angle, so that could be what it looks like. If I told you what the measure of the exterior angle looks like, can you determine what the three measures of the interior, like what each of the three interior measurements are? Yes, no, or, well, I guess those are the only two options, yes or no. What do you guys think?
Yes,
Why do you say yes?
because the two non-adjacent angles have to equal something. And so then you set up an equation and then you can figure out the last angle.
Okay, here's my question to you, Xander, and for anyone else who is thinking that though. Do we know that the two non-adjacent interior angles are the same size?
No, but they don't have to be.
They don't have to be. Okay, you're right. They don't have to be. So let's call this one X. Let's call this one Y. They could be the same size or they could be different. We know that this angle is going to be 180 minus 20. So we know that's 60 degrees. We know that for sure because we can just subtract from 180. Are there more than two numbers that add up to give you 120?
Yeah,
Yeah, it could be another 60 and another 60. So they could be the same. It could be an equilateral triangle. It could be 70 and 50. It could be 10 and 110 for all I know. You know what I mean? Like, so we aren't able to exactly pinpoint it. So the two non-adjacent interior angles could be any two angles that add to 120 degrees. Yeah, so we're not exactly able to pinpoint. We can get one of the angles down. We know that that its supplement angle here is going to be 60, but we aren't really sure what the other two angles are unless the instructions said that they were congruent, which they did not. If it said they were congruent, we'd be good to go. But if they don't have to be the same measure, they could be a bunch of different measures. Number 19, determine whether the statement is always, sometimes, or never true. Explain your reasoning. If I gave you three angle measures, you could construct a triangle. What do you guys think? I just gave you three angle measurements and said like 60 degrees, 40 degrees, and 200 degrees. Could we make a triangle?
No.
Why do you say no, Shane?
Those degrees, if they were to be added up, they wouldn't equal 180. They'd equal something way over.
You're right. On one of the angles I said was 200 something, right? So yeah, so if I just gave you any three angles, they aren't, always going to add to 180. Now, could they add to 180?
Yes.
Yeah, I could give you three numbers that do. So the answer here is going to be sometimes. Okay. If I just gave you three angle measurements, they could add up to 180, or they could fall short of 180, or they could go over 180. And if they fall short or go over, then we don't have a triangle. So the answer here is not all three numbers are going to add to 180 if I just gave you three random ones. Okay, number 20. The acute interior angles of a right triangle are complementary. So let me draw for you a right triangle. There's my right angle. It says the acute interior angle. So we'll call this angle X. We'll call this one angle Y because it doesn't say they're the same size. It says that these two angles, X plus Y, are going to add to, no, sorry, it doesn't say they add to anything. It just says they're complementary. So what's complementary mean?
The same.
Not, that's congruent. That's congruent. What's complementary mean?
2 angles equals 90 degrees.
Yes, 2 angles are going to add up to be 90. So is it possible that x plus y could equal 90?
Yeah.
Yeah,
Yeah, not only is it possible,
always.
it's guaranteed. You're exactly right. Because if I know there's 180 degrees in a triangle and this angle here is 90, 180 minus 90 is 90. So these other 2 angles always would have to add up to be 90 if we have a triangle. So this one is always. And then our last one, number 21, determine, okay, always, sometimes, or never. A triangle has more than one vertex with an acute exterior angle. A triangle can have, or has more than one vertex with an acute exterior angle. So again, let me draw you a triangle. It just said a triangle, so I don't have to draw a specific one. So let me just draw one that looks like this. Okay, I'm going to extend that line. We're going to call this X is the exterior angle. A triangle has more than one vertex with an acute exterior angle. So this is an obtuse angle. If I extend this line, let me see, extend this one, extend, whoops, hang on a second, extend this line, and then extend this line. These are my exterior angles. So it says a triangle has more than one vertex with an acute exterior angle. Now, acute means less than 90 degrees. Does it look like we have more than one angle that's exterior angle that's less than 90? I mean, the way that I drew it, this one's obviously obtuse. What do you say about angle Y? That one
Probably.
kind of looks like it's, I don't know. I can't tell if it's a right angle, if it's obtuse or acute. I can definitely see that the angle Z would be obtuse. And let's just say for sake of things, this is acute. If it were acute, it still doesn't answer our question of more than one vertex that's acute. So the answer would be here would be not for this triangle. Let me draw another one. Just trying to make them as weird as possible. Okay, so if I extend the lines here, there's an exterior angle. There's an exterior angle. There's an exterior angle. I should have used X, Y, and Z. Right there, these all look like they're obtuse. Now, let me give you some background information into this question. Since the exterior angle of a triangle is going to be supplementary with its interior angle, if you have a triangle that has an acute interior angle, like this one here I've just shaded in, it's going to have an obtuse exterior angle. So another way, let me rephrase this question. Can a triangle have more than one obtuse interior angle? Well, the answer is no. Yeah, no, it can't, because they have to add up to 180. And if you have 2 obtuse angles, you're already over 180. And so typically a triangle is going to have, now, if you do an acute triangle where all 3 angles are acute, then all 3 exterior angles would be obtuse. But even if I do an obtuse triangle, like let me do an obtuse one real quick. I can only make one angle obtuse and the other 2 angles have to be acute. So if I do an obtuse angle, yes, this exterior angle is acute, but these other exterior angles are not going to be acute. They're going to be obtuse. So the answer here is never. You can never have a triangle that has more than one acute exterior angle, because you can't make a triangle that has more than one obtuse angle. Okay, so the answer there is never. You can't do that. Okay, so sorry I ate in a little bit more of your time. I wanted to go over those homework questions. Your homework for tonight is section 3.2. If you are struggling with section 3.1 or 3.2, shoot me an email. We can talk over Zoom, or we can just chat back and forth on email. So I'll see you guys Monday. I'm assuming the roads are going to be cleared up by then, and you guys have a wonderful day.